Hello everyone. So in this video we'll discuss about the practical electricity. That's section 4.4 for Cambridge GCSE O Level Physics. So this section has two subsections, section 1 and section 2. In the first section we'll discuss about the uses of electricity, and in the next section we'll discuss about the electrical safety. So as far as the uses of electricity is concerned, we'll discuss where do we use electricity. So the uses of electricity. So we use electricity for the heating purposes. We use it for the lighting purposes. I'll also give you the examples, but for now I'm just giving you a general idea where do we use electricity like in our daily life. So it's used in heating, lighting, and it's used for like battery charging. We use it in charging for our mobile phones and our other electronic appliances, and it's also used in powering motors like fans and air conditioner and other type of motors like drill machines and industrial motors. So this is where the electricity is used, and also it is used in our electronic systems like our computers, our laptops, our mobile phones. They're all operated on the basis of electricity. So for the heating, as far as the examples are concerned, for the heating you can give the example as an electric heater. An electric heater consumes electricity. You can give the example of an electric geyser that is used to heat up the water. And then for the lighting purposes, it can be used as in the light bulb, or nowadays we have the LEDs, lighting LEDs, and other lighting appliances. For the battery charging, it's quite obvious. In the battery charging, electricity is used in charging our mobile phones, and it is also used in the charging of our backup batteries that we used in case of absence of light. So for the backup batteries, electricity is used for the charging purposes. Then powering motors. So whenever you operate a drill machine to drill a hole in the wall, and you want to use it in the fan, like in the electric fan, you can use it in the air conditioners. So the examples could be drill machine, because there are motors in the drill machine. So in the drill machines, it can be used in the air conditioner. All right. So these are a couple of examples for powering motors. Then we can also use it in our electronic systems in order to operate a desktop computer. They are practically run on electricity, and other electronic appliances can be run by the electricity, like our medical X-ray machines, our medical instruments like X-ray machines, and our Xerox machine, like they all run on electricity. So these are some of the examples that you have to keep in mind, because in the exam they will ask you about writing some examples on the uses of electricity and give the daily life examples as well. So in that case, you have to mention the use of electricity, and you have to give a couple of practical examples, and each example might carry a 0.5 marks. So it's very important in perspective of the exam. Now, the next topic this was about the uses of electricity. Now, the next thing that we have to discuss is about the lighting circuits. Why is it it is an advantage for us to use the bulb or the lamps in parallel circuit other than the series circuit? Let me review again about the parallel circuits and the series circuit. Let me just draw two circuits over here. Just simple two circuits. Let's suppose that's a battery. This bigger line is the positive terminal. This small line is the negative terminal. It is connected with the two light bulbs. Let's suppose 3 light bulbs. And the total voltage of this battery is 12 volts. So that's the electrical symbol for the light bulb. So we have 3 light bulbs and that are connected with the 12 volts battery. Now in the series, what happens with the voltage? It splits. So voltage is divided into these 3 bulbs. So each bulb will get 4 volts, 4 volts, 4 volts, and 4 volts. So if the voltage across a bulb is less, the bulb will become dimmer. But if the voltage across across a light bulb is higher, it will glow more. On the other hand, let's see a parallel circuit. So that's 1 light bulb, that's the 2nd light bulb. Here we have the 3rd light bulb. They're all connected in parallel. So in the parallel circuit, the voltage stays the same across the bulb, although the current divides, but the voltage remains the same. So let's suppose if this battery is of 12 volts, then each of these bulbs will be getting 12 volts. So in that case, the glow of the bulb will be higher than the series circuit, because each bulb is getting 12 volts across its ends. So that's why we use parallel circuits for connecting the lamps or the light bulbs. All right. So that's the advantage of the parallel circuit. And in our homes, all the wiring that you see in our homes is a parallel wiring. We don't use the series circuits in our home. Now, This is the reason that in each socket of our house we have a 220 volts, because 220 volts is the total voltage that comes from the outside transmission cables to our homes, and we have 220 volts from each socket of our home, which means all the sockets are attached in parallel to give us 220 volts. All right, so that was about the importance of a parallel circuit, and that was the importance of how and why do we use a parallel circuit to connect the lamps. Now, the next thing that we have to discuss is we have to discuss a couple of, we have to review some formulas about the power, and then we'll relate those formulas of power with the energy, with the electrical energy, and how do we calculate the energy in our daily life. All right. So as far as power is concerned, in terms of voltage and current, the power is equal to voltage times current, or we can say P equals to VI. Now, there's another equation that relates energy with the power. So energy is equal to, or we can say power is equal to energy divided by time. If we divide the energy by the time, we'll get the power. So energy divided by time is power, or we can say energy equals to power multiplied by time. So the equation can turn out to be E equals to P times T, or since our P is VI, so E will become equal to VI T. So this is the equation for the energy in terms of voltage, current, and time. So from this equation, we can get another unit of energy that we use in our practical life for the measure the electricity that is consumed in our homes and industries. So that unit is called kilowatt hour. Kilowatt hour. This is the symbol K small, W capital, and H small. Kilowatt hour. So kilowatt hour is the unit of energy, and this unit says, or we can say 1 kilowatt hour. 1 kilowatt hour is equal to 1 kilowatt hour is the energy if 1000 watt of power is consumed for 1 hour. For 1 hour. If 1000 watt of power is consumed by an electric appliance for 1 hour, then the total energy that has been consumed will be 1 kilowatt hour. So that's how you can understand the importance of the unit of energy, of electrical energy, that's kilowatt hour. So let's suppose, for the sake of example, we have a light bulb. There's a light bulb that is 100, and this light bulb, it stays on from 8 a.m. in the morning, no, 6 p.m. at night till 6 a.m. in the morning. So for 12 hours, it stays on. So the power, as you can see, is in watts. We'll convert the power into kilowatt first of all. In order to convert the watts into kilowatts, we will divide it by 1000. So 100 divided by 1000 equals to 0.1 kilowatts. So the power of this light bulb will become 0.1 kilowatt, and the time for which it stays on is 12 hours. Now, in order to find out the total energy that has been consumed throughout this lighting of the bulb, that will be equal to, you'll multiply the power with the time, and the time should be in hours. So the power should be in kilowatt. Now here the power is 0.1 and the time is 12. So 0.1 times 12, it will be 1.2 kilowatt hour. So the total electrical energy that has been consumed by a light bulb that is 100 watt and it stays on for 12 hours, the total energy is 1.2 kilowatt hour. Now, 1 unit of electricity that is being charged by the electric providing companies, 1 unit of electricity is equal to 1 kilowatt hour. Now, if in the UK the cost of 1 unit of electricity is, let's suppose, £1, then the total electricity bill for this bulb that stayed on for 12 hours will be £1.2. You'll just multiply the unit in kilowatt hour with the cost of electricity for 1 unit. So it'll become £1 times 1.2, that'll be 1.2 pounds. So that's how you can find out the total cost of the energy consumption, by finding out the units in kilowatt hour and timesing it by the cost of the unit, the cost of unit that is in pounds. So this is about the kilowatt hour, and that's how you can calculate the cost of using electrical appliances where energy unit is kilowatt hour. So we are done with the section number 1. Now we'll move on to section number 2, that is about the electrical safety. So here I have a couple of examples for the damaged insulation. As you can see over here in this area, this insulation, the rubber of the wire have been damaged, and there's some naked wires that you can see from here. So if you touch it, you will receive an electric shock. Also, the other example is very common and damage that you can often see in the power cables of the computer PCs. if there's some bend, so after a long time it gets damaged, and if you touch that, you'll get an electric shock. So you need to avoid such situations, and you have to keep an eye on all the cables in your house. Wherever you see any damage, you can just put an electric tape, or you can just replace the cable. It's very dangerous because in our homes, the total voltage that we get is 220 volts. So if you touch that, it can be proved as deadly. So the necessary measures should be taken necessarily. Now the next one is the overheating of cables. So in overheating of cables, what happens in the overheating of cables? Let's suppose a wire is designed for carrying a current of 100 ampere, and you connect a device that needs a current of 200 ampere, or let's suppose 500 ampere, and you use the same wire for an appliance that needs a current of 200 to 500 ampere. So when the more current passes through a cable, the more heating effect it will generate. So the more heating effect it will generate, as a result of that, the insulation on the wire will be burned, and that's how the overheating occurs, and that can damage your cables. And as a result of overheating, the insulation goes off, and if you touch the wire, you are more likely to get an electric shock, or you're more likely to have electric fire, because it will burn, and due to the electricity, you can often see a fire. So these are some of the examples for the overheating cables. Now the next condition that you have to avoid is the damp conditions. Damp are the moisture conditions. So whenever you are in a moisture condition, do not place any electricity cables or electricity plugs or sockets near to damp area, because moisture or the water, it's a good conductor of electricity. So whenever you place your electricity, whenever you place your sockets or cables near to the damp surface, and if you touch that surface, the charge flows through that moisture surface, and you might get an electric shock. That electric shock will be deadly, but it will be less deadly than the overheating of cables and the damaged cables. Okay, so you need to avoid all such conditions where you can avoid the damp conditions. Now the next hazard that you have to take care of is the excess current from overloading of plugs. So as you can see in this example, in one socket there are like multiple plugs. So what's going on here is, as I told you, the concept of current from the wire. Let's suppose the wire in this socket can withstand with a current of 100 ampere, and if all of these plugs that are withdrawing the current from this socket, let's suppose the current exceeds this value. So what will happen? The heating effect will come into effect. So the socket will become hot, and it can cause a fire. So this is the condition that you need to avoid, and just try to avoid excess plugs from on the socket. All right, so now we'll discuss about the fuse and the trip switches. So here you see two pictures. This one is the fuse, and these are the trip switches. I'll just explain you like how each of them work. So fuse, let's suppose this is a fuse. It will be attached to with an appliance, with our electrical appliance, and let's suppose the electrical appliance is safe to operate on with a current of 50 ampere, and this fuse will only allow maximum 50 ampere of current pass through it. If the current exceeds from 50 ampere, this small wire in the fuse, it will get heat up, and as a result of heating up, it will melt, and then it will break down. So once it heats up, it melts and it breaks down, it will disconnect the electric circuit. So when the circuit is disconnected, our electrical appliance will stay safe, and we can just replace a new fuse. We'll check what's wrong with the power supply, with the power supply that we are providing to the appliance, and then we can just replace with a new fuse, and our appliance will stay safe. So this is how a fuse works. Now, on the other hand, trip switches. Normally in our houses nowadays we see these trip switches because they're like more advanced, and each time we do not have to change a trip switch like the fuse. So what happens with the trip switch? So in the trip switch, let's suppose there is some short circuit in the house, and our appliances are more likely to burn due to that short circuit. And these trip switches, they just provide safety for our appliances to not get burned by the electricity. So whenever there's some short circuit in our house, this trip switch will turn off, and all the electricity in our home, or some sections of our home, let's suppose on the first floor of our home, all the appliances will turn off. So then we'll go and check our trip switches, and one of the switches will be in the closed position. We'll again turn it on, and then we'll identify the fault and then turn it on, and then all the circuits will operate normally. So that's how a trip switch works. So if anything goes wrong in any electrical circuit in our house, or if there any short circuit, this trip switch basically turns off, and we fix that issue, and we can again turn it back on. So we don't have to replace a new trip switch every time it shuts down, unlike fuse. So that's how these are the two uses for the fuse and the trip switches. So basically these two are used for the safety. For example, if someone get an electric shock, then it will cause a short circuit. Due to that short circuit, the trip switch will turn off, and the person's life can be saved from the electric shock. So normally nowadays we use trip switches. Before, in the past, we use the fuses, but also nowadays we also use fuses in some of the appliances where it is suitable. All right, so now we'll discuss the concept of live wire, neutral wire, and earth wire. We use live wire for live wire is the one from which the current comes into the equipment, into the appliance. Neutral wire is the one from which current goes out of the appliance, and earth wire is there for the safety purposes. But before discussing that, let me tell you how can we identify a live wire, neutral wire, and an earth wire in an electric plug. So here we have an electric plug. So here, this white color, this is the casing of the plug. This green wire that you can see over here, that's the earth wire. The blue wire that you can see over here, that's a neutral wire. And the brown wire that you see over here, this is the live wire. So the current is coming into the appliance from this blue wire, that goes into the appliance, then the appliance works, and then the current comes out from here and it goes back to the power supply from this blue wire. Now, if something goes wrong in the circuit, in the appliance, or if there's some current leakage in the appliance, then earth wire is there to protect it. I'll show you how the earth wire protect us, or how the earth wire should be necessary in all the electrical appliances, especially the appliances that are conductors, that are made up of metallic body. And over here you see a fuse. This fuse is attached with the live wire. So again, the current comes from the live wire, it passes through the fuse. From the fuse it goes into the appliance. From the appliance it comes back from the neutral wire, and from the neutral wire it goes back to the power supply. So that's how the whole circuit works. Now I can show you the colors of the neutral, live, and green wire. So live wire is of brown color according to the UK standards. Neutral wire is of the blue color, and earth wire is of green color. Now about this fuse is there. Let's suppose the appliance can only consume a current of 50 ampere. So this fuse will be of 50 ampere. Over here, this fuse is of 3 ampere. You see over here, this 3 is written. So if the current goes above 3 amperes, this fuse will burn, and we have to check the issue. We'll have to fix it, and then we have to replace this fuse again. All right. So these are the 3 wires, and that's how they work. Now let's see in the socket. So this is the electric socket where we put in the electric plug. This one shows the the earth wire. One is live and one is the neutral. So this left one is the live wire, and the right one is the neutral wire. So the live wire can also be black, it can also be brown, and the neutral wire will be of blue color, and the earth wire will be of green color. So this is the socket, and we should make sure that in our plug, our live wire should be on the left side and our neutral wire should be on the right side. We should not switch the position of the live and the neutral wires. Now that's just this electric circuit drawing. Let's suppose this is the current supply. Now the current comes from the live wire and goes back from the neutral wire. Here the current is coming from the live wire. This is the appliance. The current is consumed here, and then it goes back from the neutral wire into the current supply. Now as you can see over here, this appliance is connected to the ground. This is called ground, or we can say earth. So the case of the metallic of this equipment is connected to the ground. Ground means 0 volts. There is no voltage in the ground. So what's the purpose of grounding it? Let's suppose if there is some wire, or let's suppose this body is a metallic body, and this metallic body is touching with the live wire. Somehow the live wire touches with the metallic body. Then what will happen if someone touches this metallic body? He or she will get an electric shock. So in order to prevent that, we connect that electric body to the ground. Let's suppose the electric body is in contact with the live wire, and the electric body has also the voltage of 220 volts. When we connect the electric body to the ground, then this voltage, all the current in this electric body will be grounded, and the voltage will become 0 volts. So there will be no current in this body, in the body of the appliance, in this metallic body. So for that purpose, we use the earth wire. Now on this side, we have this neutral wire, and this neutral wire is also connected to the earth. Why? Because the voltage at the neutral wire is 0 volts, and the voltage at the live wire is the maximum for the practical electricity, or the electricity that we use. The voltage ranges from 220 volts to 240 volts, but usually we take it as 220 volts. All right. Now I'll explain you in more detail the concept of the earth wire and why do we use it. Now here, as you can see in this drawing, and this is the equipment with the metallic body as well. Now over here you can see this is the live wire. Over here the energy is being consumed. Somehow the body is connected to the live wire. So the body has also current. So this metallic body is being connected with the earth wire. So all the current that will be in this metallic body will go into the earth. So whenever someone touches this metallic body, he or she will not get the electric shock. So that's why we use the earth wire in our electric plugs. So wherever there is some current leakage, or wherever there is some electricity in the metallic body of the equipment, it can be grounded and the voltage will become 0, so we can get prevented from the electric shock. I hope you got all the concepts in this video. If you have any question, you can just write them in the comment section. I will go through each of your comments and I'll try to answer as many questions as possible. So just comment below and let me know what do you think about it, and let me know if you have any questions. So for now, section 4.4 is done, and in our next video we'll move on to the next section that will be about the nuclear physics. So for now, our electricity section has been done for GCSE Physics O Level. Take care of yourself. Goodbye.